This is the second activity for lesson 11. So the title of this activity is What We Mean by an Equation of a Line. So we're getting to this writing equations and figuring out what that means. So in this figure, you have point B and point D, and you have this triangle, ABC, or actually this length along the x-axis and this length along the y-axis. And so it says, is point 2015 on this line? Explain how you know. Well, first of all, let's figure out what the relationship is to the vertical length to the horizontal length. Once we have that relationship, whatever point is on this line will have that same relationship in the slope triangle. So this length, this vertical length is 3 units. So the horizontal length is 4 units. So the ratio of the vertical length to the horizontal length is 3 to 4. So the vertical length is 3/4 as long as the horizontal length. So in this case, the horizontal length is 4 units. 3/4 of 4 is 3 units. So the vertical length is 3 units. So this point, 4, 3, is on this line. And it gives you a relationship of the vertical length to the horizontal length of 3/4. So now what if you go out to another point on the line? Does it have that same relationship? And because this point goes through 0, 0, you can use the x and y coordinates to figure out that relationship. So this point 8 is 8 units along the horizontal axis. And how many units is it along the vertical axis or the y-axis? It's 3/4 of 8. Well, what is 3/4 of 8? Take 8 divided by 4, that's 2 units, and 3 of those 2 units gets you to 6. So this height is going to be 6 units. This is 1/4, 2/4, 3/4 of 8. So this is 6 units. So the coordinate of that point has an x value of 8 and a y value of 6. So notice the ratio of y to x is 3/4. The ratio of y to x, vertical length to horizontal length, is 6/8, which is 6/8, or 6 to 8, which is also 3 to 4. So divide 6 by 2, divide 8 by 2, and you get 3 to 4. So I just showed this relationship up here, just another way. This is the length along the x-axis, the pink. And along the y-axis, it's 3/4 that length. So this blue line is 3/4 of the pink line. And likewise down here, this pink line is 8 units long. So the blue line, which would be the vertical length, is 3/4 of that length. So this is 1/4, 2/4, 3/4, which is 6 units. And then 4/4 would be the 8 units. So 6 to 8 is a ratio of 6 to 8 is the same, an equivalent ratio to 3 to 4. So it is 3/4 as long as the horizontal length. So I'm going to build a table. So we have several points that we want to test whether or not they fall on this line. And that's what an equation does for you. It allows you to test whether or not a point is on the line and how you figure out what points are on the line. And so the first one was an x value of 4, a y value of 3. So this should take you back to 7th grade. We built these x, y tables, t tables in 7th grade. I think you even did them in 6th grade. And we figured out that the constant of proportionality, which turns out to be the slope, is the y value divided by the x value for a proportional relationship. So this is 3/4, a ratio of 3 to 4. And the x value is 8, the y value is 6. That also gives you a ratio of 3 to 4. So wherever you have that ratio, it's going to be a point on this line. All right, so let's look at 20 for the x value, 15 for the y value. So what is that ratio? It's 15 to 20. So you divide each of these by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. So that also has a ratio of 3 to 4. So 20, 15 is on this line. You got 20 units and then 3/4 of 20 is 15 units, so you go up 15 units, it will fall on this line. It will be a point on this line. How about 100 for the x value and 75 for the y value? Well, that's like having 3/4 out of a dollar, so it's 3/4. So 75 out of 100, or a ratio of 75 to 100, is the same as 3 to 4. Divide each by 25, you get 3 to 4. So if you go out 100 units, then you're going to go up 75 units, because that is 3/4 of the length up of the horizontal length, so it's going to fall on this line. And look at here. If you go out 10 units, that's 1/10 of 100. The vertical distance is 7.5 units. 7.5 units, which is 3/4 of 10. Makes sense. About 90 to 68. So 68 to 90. Well, I'm going to divide 90 by 4 because we have to, the vertical length is going to be 3/4 of 90. So if 3/4 of 90 is 68, then it works. So 90 divided by 4, that's the same as 45 divided by 2. That's the same as 22.5 over 1 out of 1. So 22.5 is 1/4 of 90. So I need 3 of those 4s. So 22.5 times 3 is equal to 67.5. Well, that's the y value is 1/2 of a unit too long to be on the line. 68 is 1/2 a unit too long. It needs to be 67.5 if the x value is 90. If this length along this x-axis is 90 units, the length along the vertical axis has to be on this line, has to be 67.5 units. And for this problem, it's listed as 68. That's 1/2 a unit too long, so it's not on the line. So for every x value, y is 3/4 of x. So that's the equation. That's written in words, but that's the relationship. That's the rule. So 3/4 of 4 is 3. 3/4 of 8 is 6. So for every x value, the y value is 3/4 of that x value. 3/4 of 20 is 15. 3/4 of 100 is 75. So 3/4 of x is equal to y. So we're going to write the rule as y equals 3/4 x. So for every value x, 3/4 of x is going to equal y. So y equals 3/4 of the value of x. So this is an equation from 7th grade. We worked with this a lot. Y equals kx, and k in this case is the slope. It's the relationship, or it's the ratio of y, the y value to the x value, because this is a proportional relationship. It goes through 0. So the slope is the vertical height compared to the horizontal distance. So the vertical distance compared to the horizontal distance is y to x. That is equal to the slope. So what do we mean by an equation? Every point on this line fits that rule. That's the equation. So every point on this line, the vertical height, the vertical length is 3/4 of the horizontal length. If you go to a unit of 1, so x is equal to 1, what's the vertical length going to be? The height along the y-axis, it is going to be 3/4. 2, it is 1.5, which is 3/4 of 2. So it works. All right, so that's activity 2 from lesson 11. What we mean by an equation of a line.